All right, so for today's lesson, it's simplifying variable expressions with rational exponents. So rational exponents basically means rational is like fraction. So we're going to have variables raised to a fractional exponent. So we'll have something like an x to the 2/3. That's what this lesson is about. And then we're going to be simplifying them. And then the objective says, I will be able to simplify variable expressions with rational exponents. All right, so concept here says a rational and irrational numbers expressed in radical form. So this radical form would be like the nth root of b. Can also be expressed with fractional exponents. And then when the number has a fractional exponent, it's said to be in rational exponent form. So this b to the 1/n would be the rational exponent form. Okay, so the radical form is when you have the square root symbol, nth root of b, and a rational exponent form is when you have it raised to a power that's a fraction. Okay, and then we see some examples here. Well, not examples, but the concept of what it means. So if I ever have a b to the p to the nth power, the denominator basically, I'm not going to highlight the whole thing actually. The denominator, you see the n in the denominator, that's your root or your index, like the nth root of b. And then the p, the numerator, is actually the power. Okay? So again, the p is the numerator, that's the exponent, like raised to a power of the numerator. And the denominator is the index or the root, the nth root of b. Okay? So for example, an x to the 2/3 would be, the 3 would be the index, the root, third root of x, and then the 2 is the power. So I'd raise it to the power of 2. Okay? Or you can put the squared next to the x. It'd be the cube root of x squared is also the other way you can do it. Okay? Or it could be the cube root of x squared. Okay? So just for like definitions here, index is the n, like the nth root is your index. Radicand is whatever's under the radical, and then the radical symbol is basically the square root symbol. Okay? And then it says here we have a prior knowledge, but I don't think this is really prior knowledge because we skipped the lesson that we used to do, so I don't think we've ever really done this, but the prior knowledge could be your exponent rules. If I have x to the n power times x to the nth power, do you guys remember what do we do to the exponents? Do we add, subtract, or multiply the exponents? Add. It would be m plus n. Okay? We would actually add the exponents if they're being multiplied by different powers. But that only works if it's the same base, okay? It only works if this is the same base right here. So like here I have a 16, they're both 16, so then I can add my exponents, okay? So for my rule is to add. So I would do 16 to the 2/6 plus 1/6. We would add the exponents, okay? So it'd be a 16 to the how do we add fractions? But do I also add the denominators? No. The denominator stays the same, right? You only add the numerators. So it's only at 2 plus 1 is 3 over the denominator stays the same, 3 over 6. So what about the other 16? Because the rule, this 16, they kind of just combine. So just like if I have x to the n times x to the n, you take the base, stays the same, and you only add the exponents. So the 16s kind of combine together. Okay? But then this 3, 6, I can still simplify that 3, 6 by 3. So it would be a 16 to the 1/2. Because I can divide both of them by 3. And then we just learned about this 16 to the 1/2. I can rewrite this as the square root of 16. And what is the square root of 16? 4, right? 16, square root of 16 would be 4, because 4 times 4 is 16, yes? So my final answer is 4. Okay, then I have this 125 to the 4/3. This is basically kind of just practicing with the, this is like a b to the p over n. It's the nth root of b raised to the p power, okay? So take the fraction, the denominator is your index, and then the numerator is your exponent power, okay? So I'm going to take the denominator part, the 3, and change it to the cube root of 125 raised to the 4th power. Okay. Then you look at your table of roots. You guys should have it like in the back of your booklet or something. Table of roots. I have it up here also. It's the cube root. So you look at the n to the 3rd of 125, which is here. So my answer is 5. The cube root of 125 is 5, right? So this becomes 5 to the 4th power. So 5 to the 4th power, that's 5 times 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Times 5 again would be 600. 625? Sorry. 625. I don't know what I just did. My screen got dimmer. Okay. Is that 625? I think it is. Yes, 625. So our answer is 625. Okay. All right. So we'll see this later today in our lesson. I just wanted to kind of, it's not really like a prayer knowledge. I don't think we ever went over this with you guys, but let's go over all of our exponent rules. So we have properties of rational exponents. It says for all non-zero real numbers a and b and rational numbers m and n, we have all of these different properties here, okay? So if I have the product of powers property, meaning we already saw this one, a to the m times a to the n, the rule is to add the exponents. And that only works when you're multiplying powers with the same base. The rule is to add the exponents. A to the m plus n. Okay? All right, then we have the quotient of powers property, meaning if I have a fraction with both the numerator and denominator have a power. My rule is to subtract the exponents, okay? So I would take the numerator exponent minus the denominator exponent, okay? Numerator minus denominator. That's my rule, okay? All right, then I have a power of a power property. Power of a power means if I have something raised to a power, raised to the other power, like an exponent inside a parenthesis, raised to another power, my rule is to multiply the exponents. So a to the m times n. Then I also have this power of a product property, which means if I have something multiplied inside the parentheses raised to a power, my rule is to distribute the exponent to each one individually. Okay, distribute the exponent. I would go from like the m distributed to the a, distributed to the b. And then the same concept applies with the power of quotient property. If I have a quotient like a fraction raised to a power, then I also distribute the exponent. So I can see a to the b raised to the m. You would distribute the exponent to each piece of the fraction. So then it'd be a to the m over b to the m. Okay. Then I also have the negative exponent rule. So negative exponent property, basically saying moving in power from numerator to denominator is going to change the sign on the exponent. Okay. So if I ever have a negative exponent, a to the negative n, I can really make this like a over 1. And I'm going to flip it over to the denominator. So take the the exponent that's negative, move it to the denominator, and then it becomes positive. Likewise, if the denominator is in the exponent that's negative, I can move it to the numerator and it becomes positive. Okay? And then we have this zero. The zero exponent property says basically anything raised to the 0 power is equal to 1. Okay? So those are all of our exponent rules. So let's go ahead and see some examples for today. Can I have you guys copy this example on your notes for me, please? X to the 6 over 5 times x to the 1/5. All right, so this is something being multiplied raised to power. So I have like a x to the m times x to the n. So what's my rule? What do I do to the exponents? Add, subtract, or multiply? Yes. We add m plus n, right? So I would then do x to the 6 over 5 plus 1 over 5. And then what's 6 plus 1? 7. So I got 7 over 5. And I can't simplify 7 over 5. Those are both prime numbers. I know it's improper fraction, but that's okay. That's going to be our final answer. So next example, please go ahead and copy. We have y to the 5 over 4 divided by y to the 3/4 power. In this case, I am dividing powers, so x to the m divided by x to the n was my rule. What do I do to the exponents? Add, subtract, or divide? Or multiply? What do I do to the exponents? Subtract. M minus n. You take the numerator minus the denominator's exponent, okay? So this is going to be a y to the 5 over 4 minus 3 over 4. Now what's 5 minus 3? 2, so I got 2 over 4. And I can simplify, those are both even, so I can simplify by 2. That's going to be y to the what power? 1/2. Good. So that's my final answer, y to the 1/2 power. Okay. All right, so this next example, it's a power to a power property. Go ahead and copy this one. We have x to the 3/4 raised to the 2/3 power. X to the 3/4 raised to the 2/3 power. I have a, basically this means x to the m raised to the nth power. What is this rule here? Exponent rules. This is power of a power, or power to a power. Was my rule with the exponents. Add, subtract, multiply, or divide the exponents. Multiply. This is x to the m times n this time, okay? So I would do x to the 3/4 times 2/3. Okay? And then for fractions, there's two ways you can do this. You can cross cancel, cross simplify as much as possible, then multiply. Or you can multiply across and then simplify later. So like for example, was 3 times 2 and 4 times 3. But then I can divide both of those by 6. That'll give me a 1/2 power. Yes? X to the 1/2. Or I suggest doing it this way because sometimes you might end up with bigger fractions and you might not be able to simplify with bigger fractions. So you can do x to the 3/4 times 2/3 and cross cancel before you multiply. So like here, 3 goes into itself once, 3 goes into itself once. And then 2 goes into itself once and into 4 2 times. Then you can multiply x to the 1 times 1 is 1, 2 times 1 is 2. So you get the same answer. Okay? So again, the power to a power, you multiply. I suggest simplify before you multiply so you can get it already in simplified form. If not, if you do it this way, you might end up with bigger fractions like a 48 divided by, I don't know, 96. You might end up with 48 over 96 and you might not know how to simplify that with bigger numbers. All right, you guys go ahead and practice this one. Okay, next example. Can I have you guys copy this one? 3x to the 5/2, parenthesis, negative 2x raised to the negative 3/2 power. We're doing this one together. I'm just waiting for you guys to copy it. 3x to the 5/2 times negative 2x to the negative 3/2. Okay, ready? What do these parentheses mean? What operation? That's a multiplication, right? So because this is a multiplication, you want to take the number part, so like 3 and a negative 2, multiply those first together. I'm going to do a step here. You do not have to do this step. I'm just going to write it out so you understand what's happening here. But this is going to be basically 3 times negative 2. And then I'm going to take the variable portion and multiply those together. This is now going to be x to the 5/2 times x to the negative 3/2. Okay? And then what's 3 times negative 2? That's negative 6. And then what's my rule here? When I multiply, what do I do to the exponents? The rule when we multiply x to the m times x to the n, what do I do to the exponents? Add them, right?
Oh, the first one was the x.
So I go 5/2 plus a negative 3/2. So that's still a negative 6 there. And what's 5/2 minus 3/2? 2/2, which is going to give us just 1, basically. So negative 6 times x to the first power, or just negative 6x. Because, again, 5 minus 3 is 2, yes? And then 2 divided by 2 is 1. So it's x to the first, or you can just leave it as x.
Oh, okay, I get it now.
Okay? Now, you guys can skip this step and you can skip this step. I don't need to see all of this work right here. I was just showing it really explicit so you understand kind of where things are coming from. Okay? But I can just go 3 times negative 2, that's negative 6. And I know I'm going to add them. So 5 plus negative 3 would be 2. And then 2/2 is 1. You can skip all of this right here. If you can do that all in your head, you can skip to this step and then just simplify the fraction. Okay? All right, you guys go ahead and try this one. Let's look now at, this is a product of a power. So I'm taking a product here, things multiplied, raised to a power. So product of a power, my rule is to distribute the exponent. Sorry, I didn't give you guys time to copy it. So go ahead and copy it before I start doing this one. Negative 5x to the 7/2 raised to the second power. All right, again, the rule here, I have a product raised to a power. So I have to distribute the power to each portion. Take the 2, distribute it to the negative 5th, and then take this x to the 7/2 raised to the second power. Okay? Distribute the exponent. So this is going to be negative 5 to the second power times x to the 7/2 raised to the second power. Okay, and what's negative 5 to the second power? Negative 5 times negative 5 is 25. And then what's my rule here? Is that power to a power? This is x to the m times, x to the m raised to the n power. So what's my rule with the exponents? Multiply. This is m times n, right? So take this 7/2 times 2/1. You can cross cancel. Like 2 goes into itself once and into 2 one time. So I'm left with x to the 7 times 1 is 7. 1 times 1 is 1. So it's just x to the 7th power. Okay. The other way, again, you can do it is 7 times 2 is 14. And 2 times 1 is 2. So 14 divided by 2 is still 7. Okay. Now what if I get something like this? Go ahead and copy this one. 27x to the 3/4 raised to the 2/3 power. Twenty-seven x to the 3/4 raised to the 2/3 power. Again, this is a product to a power. So my rule is to distribute the exponent. So 27 to the 2/3 times x to the 3/4 raised to the 2/3 power. Okay? And look back to your prior knowledge. What did we do this with this? Like a number raised to a rational exponent. What do I do here? Look at your prior knowledge. This is a b to the p over b, right? It's going to be the b of the, so the b root. Oh, my bad. That was supposed to be an n. They're both b's there. My bad. This is supposed to be an n. So this is the nth root of b raised to the power of p. Right? So I'm going to take the denominator, and that's going to be my root. So this is going to be the cube root of 27 raised to the power of 2. Okay? My numerator becomes the exponent, and then the denominator is your index, your root. So cube root of 27. Okay? Look at your table for the cube root of 27. N to the 3rd power of 27 is 3. Cube root of 27 is 3. And then I get a 3 raised to the 2nd power. What's 3 to the 2nd power? 9. And then for the other one, we multiply again, so we can cross cancel. 2 goes into a self once and into 4 2 times. 3 goes into a self once and into self once. So I'm going to be left with x to the 1/2 power. And that's my final answer. Okay? All right, that's kind of the end of our lesson for today. Don't worry about the homework. We'll just do it in class on Monday.